So in this case, we're looking once again at quadratic equations. Y equals ax squared plus bx plus c. And we're looking at how does a affect the graph in y equals ax squared first. So just the a value itself. I know it's kind of hard to see our equations there, agreed? So let's keep in mind that this is our standard quadratic equation format, the full figure of it. But let me rewrite the formula for you there. That way it's a little bit easier to maybe see, I hope. Y equals 2x squared is the first graph. That's the one in brown. And let's realize that our a value there is 2. The next one is y equals 1x squared, and the a value for that one, a is 1. I could have had as just y equals x squared, and it'd still be a 1, be aware of that. And the last one there, y equals 0.5x squared, or 0.5x squared. So our a value is 0.5 or 0.5. So what do we notice here between our graphs? So one thing that we can notice is if a is an absolute value, meaning larger number. So as a is larger, then the parabola is steeper or it's narrow. So if a is a large number, then the parabola is steep or narrow. You kind of got the wrong absolute value location. So absolute values, technically in the wrong spot though. Okay, go for the next one. If absolute value of a is small, okay, number near 0, then the parabola is not steep or is wide. So in other words, notice if we go from the bottom up on that graph on the left side, as you go up in the a value, if you increase the a value, your parabola becomes narrow. Okay, so it starts to close in, sort of like a mouth, let's say. Okay, going for the next one. Down at the very bottom right on the graph there, if we have our equation y equals x squared, in this case, we can see that a is positive 1. Once again, I didn't put a 1 in this case for reference. And then the bottom one, y equals negative x squared. In other words, we could say it's a negative 1. So a equals negative 1. So if a is greater than 0, then the parabola opens upwards. And it's a U-shape technically, right? So for a, that's the top case scenario, the blue graph. On our bottom graph, two graphs that are upside down, both, or reciprocal of each other, technically, however you want to see it. Then in this case, we say it opens up because a is greater than 0. On the other hand, if a is less than 0, that's the brown example at the very bottom, then the parabola opens downwards. So, in general, the equation y equals negative ax squared is a reflection of y equals ax squared across the x-axis. Hence the reason why we see it upside down. So not necessarily the reciprocal, but it's a reflection of each other. Okay. So let's go for our next view of this. So we saw how a affects the graph for our equation y equals ax squared plus bx plus c. How does b and c affect the graph in y equals ax squared plus bx plus c? So let's see. Y equals x squared plus 5x is our first case scenario. On the top left graph there, that's the brown graph on the left side. And let's realize that our vertex down there, it's sort of to the left side of our y-axis, agreed? So there's the v-value actually, v-value of 5. Next case scenario, that's the blue line, y equals x squared plus x. Now let's realize that's in the middle. So v-value is technically 1 for that one, and it's basically sort of center by comparison. Okay, next case scenario, the green graph, y equals x squared minus 5x. And let's realize that the v-value is negative 5. Once again, I'm not telling you that the vertex is 5, 1, or negative 5. I'm just stating what the v-value is for each of those equations. So notice what or where our vertex is. So if you have a positive value, it's shifted to the left. Positive v-values shift to the left. Negative b values shift to the right. So negative b values shift to the right. So opposite probably of what you thought, right? Positives, you thought it was going to go to the right, but no, it goes to the left. Negative values shift your graph to the right. Okay, let's look at the bottom graph. Y equals x squared plus x plus 5. The c value in this case. Looking at the c value, it's 5. And it actually tells us the y-intercept, 0, 5. So the z value is the y-intercept location. And technically you can see it there on our graph. It crosses our y-axis at 5. Okay, next equation, the blue one at the bottom there. Y equals x squared plus x plus 0. So in this case, we can see that the y-intercept is going to be there. And we can see the y-intercept is actually 0, right? Because everything goes to 0 for that case. So 0, 0. So we have the y-intercept via the graph, or the y-intercept via your equation there. You can plug in for 0 and get a 0 at the end. So the z value is the y-intercept location. So in this case, that is essentially how it's defined, or what defines our graph for this particular case. How about if we have it in Vertex standard form? Remember, that's our other format. We had it in Quadratic standard, but this is Vertex standard. So the Vertex actually tells you where your vertex is. Looking at the very bottom, it would tell us on the green graph where the vertex is. It's at the bottom left. So this is the standard vertex form of quadratic equations. And the vertex is given as h, k. Notice it's in your formula. Y equals a times parentheses x minus h parentheses squared plus k. You have the h and the k stated in your equation for the vertex form of the quadratic equation. So let's depict where our vertex is. And notice this one I stated the equation a little bit bigger. So the vertex, let's see where they're at. For the first equation, the green graph, we can see that the vertex is at, remember it's h, k, it's involved in your equation. So you have a positive 5 and negative 5, as you can see in the first equation. But be aware, that first sign, it's a little tricky. The h is always opposite of what you have in the parentheses there. So opposite sign for that one. In other words, it has to be negative 5 for this case instead of positive, because your equation normally has a negative sign on it. So in this case, negative 5 would be our x value, and the negative 5 that remains would be the k value on our equation there. There we go. There is our vertex. And we can visually see in our graph there on the left. Let's go for the second equation, the blue line, and we can visually see it on our graph where our vertex is, the lowest point. Seems to be at 0, 0, agreed? And we can actually see in our equation it has a 0 and a 0 for k, h and k both. So notice in this case the sign doesn't matter because 0 is a neutral number. So 0, 0 would be our vertex location. And last but not least, we can see once again where our vertex is, roughly at x is 5. And in this case it would be a 5 as well for the y value. Or we can see it in the h and k representations that are in our equation. Notice in this case we have a negative 5. Remember, it has to be the opposite sign. So it's a positive 5 instead of a negative 5. But our k value is exactly positive. So there is our vertex locations for all of this. This is using the vertex standard form of the quadratic. Okay.